Hello everyone. So let us welcome to our presentation on the Smurf attack with ICMP. This topic delivers into an early yet impactful type of DDoS attack that exploits the Internet Control Message Protocol. Our goal is to explore the technical details of the attack, its real-world impact, and the method we can use to defend against it. So let's begin. These are the list of our group members. So let us introduce us to you. My name is Aditya Verma.
Hi, I'm Vivek Venkatesan.
Hi everyone, my name is Chamadit Singh.
Hi everyone, my name is Siddharth Srikumar.
Alright, thank you everyone. Moving forward comes to the introduction. So thank you all for being here today. Our presentation focuses on the cyber attack techniques known as Smurf attack, which exploits the Internet Control Message Protocol or ICMP. This attack is a form of distributed denial of service, which is DDoS, that can cause significant disruption to the system and networks. Over the course of this presentation, we will explain you how Smurf attack works, the impact they have, and the strategies we can use to prevent the to mitigate them. So let's get started with it. So as you can see, this is our table of content. In this, we are going to cover what is the Smurf attack, understanding ICMP, how Smurf attack works, component of Smurf attacks, Smurf attack application factors, impact of Smurf attacks, real-world examples of Smurf attacks, mitigation techniques, best practices to prevent them, and modern-day relevance. And the second last comes is the comparison with other DDoS attack. And our last page is our thank you page, which is the question page if you have any. So, moving forward, let's start with what is Smurf attack. A Smurf attack is a type of distributed denial of service or DDoS attack. In this attack, an attacker overwhelms a target system with an enormous amount of ICMP reply packets. These packets make it look as though the victim requested the traffic. The attacker does this by spoofing the victim's IP address and broadcasting ICMP requests to a network, causing all devices in the network to respond to the victim's IP. This results in the victim's system or network being overwhelmed and unable to handle legitimate traffic, effectively causing a denial of service. What makes this attack particularly dangerous is its simplicity and how easily it can exploit misconfiguration of the network. Moving forward, let's understand what is ICMP. Like, we are going to understand the ICMP here. To understand the Smurf attack, we need to understand ICMP. The Internet Control Message Protocol or ICMP is a network layer protocol used by devices to communicate error messages and operational information. For instance, when you ping a server to check connectivity, that uses ICMP. However, ICMP lacks authentication mechanism, making it vulnerable to abuse. Attackers can exploit ICMP's broadcast functionality to amplify traffic and overwhelms a target. This makes it common target in denial of service attack like Smurf. Moving forward, how Smurf attack works. So first, the attacker sends an ICMP echo request packet to the broadcast address of a network. A broadcast address sends the request to all devices within the network. The attacker spoofs the source IP address of this packet to match the victim's IP. All devices in the network receive this request and respond with ICMP. Echo relies directing the replies to the spoofed IP, which is the victim's address. The result is an overwhelming flood of traffic to the victim, disrupting its ability to function. This type of attack is particularly effective because it uses the network device as amplifier. Moving forward, my other teammate Vivek will let you know what are the components of Smurf attack. Thank you.
Hi, I'm Vivek Venkatesan. And the components of Smurf attack there are three main components in Smurf attack. The attacker who initiates the ICMP request, and spoof the victim's IP address. The amplifier, which are the devices in the network responding to the ICMP broadcast, these devices unknowingly participated in the attack. The victim who receives the amplified traffic and experiences service disruption. Understanding these components helps us identify weak points where mitigation measures can be implemented. Smurf attack amplification factors. One factor that makes Smurf attack so powerful is the amplification factor. Imagine a network with 100 devices. A single ICMP request to the broadcast address will trigger 100 ICMP echo replies. If an attacker sends multiple requests, the traffic directed at the victims multiplies exponentially. This amplification is why Smurf attack can cause significant damage with relevant little effort on the attacker's part. It demonstrates the need to secure network against misuse of broadcast functionalities. When talking about the impact of Smurf attack can be severe. First, they cause severe outages by overwhelming the target system, preventing legitimate users from access services. Second, they increase latency, degrading system performance. Third, they can result in the financial losses of businesses due to downtime and recovery effects. Finally, the damage the reputation of the organization affects, especially if the customer service are disrupted. Their consequences highlight why such attacks are major security concerns. Real world examples of Smurf attacks. Smurf attacks were particularly common in the 1990s and early 2000s, when many networks allowed ICMP broadcast by default. For example, organizations experienced significant disruptions due to attack exploitation, large-scale broadcast domains. When modern network configuration has reduced the prevalence of Smurf attack, they said they serve as an important lesson in why network security practices must evolve. Mitigation techniques. Network level solutions. At the network level, we can mitigate Smurf attack using the following techniques. Disable directed broadcast. Configure routers to reject broadcast packets, preventing the amplification effect. Filter ICMP traffic. Using firewall to block untrusted ICMP traffic from reaching internal networks. Ingress filtering. Prevent packets with spoofed IP addresses for entering the network. These measures target the attack at the source, stopping it become before it reaches the victim. From here, my other teammate Samandeep will be taking over.
Thank you, Vivek. My topic is mitigation techniques at host level solutions. At the host level, additional measures can be taken. Configure firewall to reduce unnecessary ICMP functionalities. For example, block ICMP echo replies unless required for network diagnosis. Sensitive devices that do not need to interact with ICMP traffic. These host-level configurations reduce the chances of system being used in attack or being victims themselves. Then, best practices for prevention. Prevention is better than cure. Here are some best practices to avoid Smurf attacks. Regularly updating and patch all network devices to fix vulnerabilities. Monitor network traffic for unusual patterns such as spikes in ICMP traffic. Educate IT teams on recognizing and responding to DDoS threats. These proactive strategies help to safeguard network against not just Smurf attacks but other similar threats. Then modern day relevance of Smurf attacks. While Smurf attacks are less common today, they remain relevant as a case study in securing protocols like ICMP. Modern networks are better configured to block such attacks, but the underlying principles of amplifications are still in under other DDoS attacks, such as DNS amplifications. By studying Smurf attacks, we learn the importance of securing legacy systems and keeping up with evolving threats. And comparing with other DDoS attacks, Smurf attacks are just one type of DDoS attacks. Others include SYN floods, which exploit TCP connection DNS amplifications, which uses misconfigured DNS servers for traffic amplification. By understanding these different types, security professionals can create layered defenses to protect against a range of DDoS threats. Now my next group member is going to present his part.
Hi, Professor. My name is Sri Kumar. From here on, I'll be taking over the presentation. So coming to the first screenshot, so what we have done here was creating a Python executable bash file for a better control for initiating the attack. So in this bash file, we can add the payload size, the count of the ICMP packets and everything, and we can get a better control of for initiating the attack. So the command we use for executing this attack is sudo python 3 and the bash file we created. Now moving on to the next screenshot, we can see the bash file with all the credentials and everything on them. So this is the bash file. So as we can see, there is the packet count size, the payload size, the victim's IP, the broadcast address, and everything mentioned on this Python file. And moving on to the next screenshot, we can see I have used the TCP dump to see the log files from the web host, which was accessed by SSHing through the NMS host VM. So using the TCP dump command to see the logs, this command is used to capture and display the network traffic on the ENSS interface. So now coming to the next screenshot, we have used the log analyzer tool to monitor the logs from all the 4 VMs, and we can see here it is highlighted a kernel level warning to the web host showing that the CPU usage have gone up since the start of the attack. So now coming to the next screenshot, we can see there's a kernel warning. I mean, the info coming from the Kali VM, which is used as the attack VM, which is mentioned as entered promiscuous mode. So what a promiscuous mode means is that it can increase the network traffic overload. So the Smurf attack floods the victim's network with ICMP echo replies, overwhelming the network interface. So this can cause the network adapter to switch to promiscuous mode to handle the excessive traffic and try to process all incoming packets. And coming to the same screenshot, we can see above there is 2 more kernel level infos coming from the web host stating that it has entered the promiscuous mode as well. Now coming to the final screenshot, we can see after initiating the attack, after starting the attack, the Kali have entered the promiscuous mode, and after I stopped the attack, it has gone down and it left the promiscuous mode. So that's it for the attack, Professor, and that's it for our presentation. Thank you for listening.
Thank you everyone for having your time.